Introducing Bytum, the ultra-precise GPS network that powers the digital railway for autonomous vehicles. What makes Bytum so unique? It all starts with the relationship between its two hardware components, the connector and the beacons. You see, the connectors are integrated into a car's computer system. It then communicates with super small radio frequency beacons that are attached to existing cell towers or utility poles. As you're in the car, Bytum uses patent-pending trilateration and proprietary angular mathematics to determine your exact location down to a millimeter. And then layered on top of that, Google Maps. And now, the car knows exactly where it is in relation to the road and can be given instructions on where it needs to go, moving smoothly along the Bytum digital railway. Bytum's ultra-precise GPS approach has major advantages over competitors like Google and Tesla's autonomous vehicles. To understand these advantages, you need to first distinguish between the static and dynamic environment and how it relates to solving challenges within the autonomous vehicle space. The static environment is when there are no objects on the road. The car should be able to navigate fully autonomously, knowing exactly where it is in relation to the road as it's driving. Then if you layer on top of that the dynamic environment, now the car has to deal with other objects on the road as well as the human interaction. Bytum's approach compared to all other autonomous vehicle companies is fundamentally completely different. To explain the differences, we will use a software railway analogy. Let's start with the competition. As the car is driving, it's acquiring vision data and running that data through AI models to predict probabilities that instantly analyze the world as it perceives it, knowing where exactly the car is in relation to the road, all while simultaneously adding individual rails that aren't always aligned properly, computing thousands of gigabytes a second. Tesla and Google and every other autonomous vehicle company are going for a one-size-fits-all approach, trying to solve all components within the static and dynamic environments using artificial intelligence. In doing so, they are only half solving all three problems and are running into issues related to scalability and cost. And at this pace, it may take 5 or more years to get to the next level of automation. Now compare this to a Bytum-powered car. As the car drives in the static environment, it mathematically knows exactly where it is in relation to the road, and the software railway infrastructure is predefined and aligned correctly with the road. When handling the dynamic environment, Bytum leverages the car's existing ADAS, Advanced Driver Assistance System, to detect any objects on the road. Bytum is the definitive complement to the ADAS because knowing the car's location to a millimeter scale allows the ADAS to more precisely detect distances and speeds of objects, so it can safely navigate around those objects. Bytum's advantage doesn't just end there. Because Bytum uses significantly less computing power to navigate elements of the static and dynamic environment, it can now dedicate that excess computing power to focus on navigating the dynamic environment with computer vision and artificial intelligence models, whilst the competition must distribute computing power across all elements of the static and dynamic equally. This backwards process has handicapped Tesla and Google. A key example is they cannot exit off a highway in their current form and cannot even operate in heavy rain. As for Bytum, it can handle exiting off a highway even in the rain like a champ. The Bytum era of autonomy is coming.